As NFV and other technologies will soon support the realization of 5G, Sprint expects that all core functions to eventually be cloud native. Along the way, Sprint is carefully managing their migration to mesh fully with the holistic goals of the company and the infrastructure requirements mandated by 5G. On this executive panel from Barcelona, Spain, we'll find out how a major mobile operator will be embracing the promise of cloud-native technologies. We're joined by Ron Marquardt. He's Vice President of Technology at Sprint. And next to him is Martin Taylor. He's Chief Technology Officer at Metaswitch. And gentlemen, welcome.
Thank you.
Well, thanks for being here. Again, I mentioned we're here in Barcelona, Spain. A lot of talk about cloud native and cloud native technologies. Really good to have both of you for some very important reasons that we'll get into in just a moment. Martin, I'd like to start with you. Metaswitch really being one of the sort of the real McCoys, if you will, of cloud native and cloud native technologies. Can you walk us through maybe a bit of a history of where you came from as far as that goes and that relationship back with Sprint?
So we started developing cloud-native communication software about 6 years ago, and that was actually before NFV was even a thing. That happened in 2012. Cloud-native software is all about building software systems that are designed from the ground up to run in the cloud. It's a very, very different design approach to software than building software to sit inside an appliance. And of course, it's the way the web scale guys do stuff. So systems that are decomposed into individual building blocks, microservices, very scalable, very resilient. That's why the web scale guys go for this kind of approach. As I say, it's a fundamentally different architectural mindset than building software for an appliance, but obviously great reasons for going down that path. And rapidity of innovation is one of the good reasons. So you decompose to microservices, you can incrementally enhance the individual building blocks without having to go back and retest the entire system, which is one of the reasons that it takes so long to evolve software when it's confined to a monolithic architecture inside a box.
Ron, the cloud native approach and its relationship to 5G.
Well, it's extrinsically important to 5G. The standard itself is now moving more to a software definition than a traditional telecom interface definition. And so it's important for us, obviously, to implement 5G, but even before that, we really want to get to the point where we're proficient at scale in cloud.
So Martin, talk a little bit more about cloud native applications, and you talked earlier in our pre-panel conference about the removal of vendor lock-in, and maybe that's not necessarily the case as people talk about that so much. Can you go into a little bit about that?
Well, open source certainly plays a big part in the evolving world of NFV. One of the things that we've, I think, done quite well is to leverage open source components very effectively. In the solution that we've delivered to Sprint to support voice over LTE, there are many, many individual pieces of open source software. Now that has enabled us to develop a solution much more rapidly and at lower cost to ourselves than if we'd had to write 100% of the code ourselves. However, it takes a vendor with a lot of know-how and a lot of knowledge in the particular space, the domain of IP multimedia subsystem IMS, to actually put such a system together. So although there are a lot of open source building blocks, there is a very, very strong vendor surround, if you like, that sits behind that. And that's critical to a customer like Sprint, who needs someone that can stand behind these building blocks, hold it all together, and take it forward and support it.
And from a vendor lock-in perspective, it's very different with NFV. Even whether it's cloud native or not, it's still very different when you're virtualized, because you're not really buying into a proprietary system, that physical hardware that frankly has to sit around for probably 7 years to amortize it off your books. The contractual obligations between the companies may be structured very differently, and you can be much more agile in how you bring on services, but also if something's not performing, how you bring them offline and replace them with something else.
Now, of course, we've talked about cloud native for a couple minutes, but there's some people out there who may not be fully grasping what that is. Martin, can you explain that to us?
Yeah, so the first thing, of course, is that in the cloud, you've got very generic hardware. You can't depend on any specific properties or characteristics or capabilities of the hardware. It's just completely generic processing power. And that's very different from the appliance world, where you're writing software to a very, very specific hardware interface. And of course, there's no specialized hardware capability that you can rely on. So you want to get good performance, you have to understand how to get good performance out of that very generic commercial off-the-shelf server hardware. And then of course there's the architecture of the application itself. As I said earlier, decomposing into microservices, individual building blocks, individual development teams working on each building block kind of independently, very loosely coupled interfaces between components so that they can evolve differently at different times, and making the thing very scalable and very resilient. So with an appliance, you scale up with very large kind of chunks of functionality in a box altogether. In a cloud-native application, you scale out, you instantiate more and more virtual machines or containers doing the same job, and each different job may scale differently. So you may have some storage functions that scale according to the number of subscribers you've got, and you may have some message processing functions that scale according to the amount of activity you've got. So the scaling is very linear and very resource efficient. And finally, of course, fault tolerance is all about having a herd of processing instances where any individual one dies, it has very little impact on the overall performance of the system. So you get very efficient fault tolerance out of the system.
Ron, in the cloud native space, if you will, a lot of experience with Metaswitch over the last several years in particular. Can you, again, walk us through maybe the history there and what your experience has been? Well,
actually, my history with Metaswitch goes back 3 companies now. I've been working with them on and off in different fashions. Martin maybe undersold what Metaswitch can do from the point of view of saying they were doing cloud for, what did you say, 6 or 7 years. They've been a software company since I've known them. They've never really been a proprietary network vendor. They've been a software company, and that's very important to me as we move into this cloud and virtualized space, because they think like software developers. They always have. They're not transitioning a business which has its own overhead and complexities in moving from a proprietary model to a software model. And that's very important. At Sprint, the first engagement was really not specific to their product, more so generally giving advice and consulting on virtualization in general, what we should look out for, helping us out in the lab, getting instances going. My team does a lot of early work, exploratory work at Sprint, and generally has the time to kind of be hands-on and figure stuff out themselves. But what really helped was to have some key experts from Metaswitch come in and help the people who actually develop the services, and that's a much more intensive job than what my team does, get them comfortable with the concept of virtualization. Because when you've been working for years with proprietary boxes, you get used to a certain way of doing things. And the concept of having a server platform there and is very different from most people who've been in telecom a long while. And they didn't quite believe that you could turn up a complete IMS in 24 hours. And that's essentially what was proven early on. Not so much, it was obviously part of what they were doing to sell to us, that they could do that, but more generally it was helping us get comfortable with virtualization and what's possible there.
Could you go into a little more detail about, and of course, Sprint's somewhat, if not very selective with the vendors that they used for their NFV ecosystem. Can you go into a little more detail about the criteria for those vendors?
Well, I think that it's fair to say that for Vultee, we've tried to go down a best-of-breed approach. So rather than picking a fully integrated solution from one large vendor, we've chosen to go and find different piece parts that we feel are the best. And that takes on more integration risk on our end, but gives us comfort in the overall ability to have the best possible solution in each space that we're choosing. We also very deliberately wanted to go, and at least for some of the VNFs, go with smaller, more agile companies to help us along, and also to show us what the art of the possible is in a way, again, that they're not encumbered by a legacy system or trying to maneuver their business around a changing business model. And so for us, it was very natural to go work with a couple of smaller vendors, including Metaswitch, both because of their expertise and because specifically they were best of breed in what they do.
Of course, Metaswitch very much behind open source initiatives, open source projects. Again, just as Ron did, can you go into a little detail about the history there and where you are now, maybe the state of play for open source right now?
Yeah, so there are a couple of different angles here. I mean, one is that our approach to building cloud-native applications is never to write a line of code if there is a decent open source project out there that you can use as a building block. Our Clearwater IMS core has something like 50 different identifiable pieces of open source code in it, amounting to millions and millions of lines of code. And that's just prudent development process. Now, you have to be selective here. There's lots of open source out there, but not all of it is good, and not all of it really measures up to the high quality bar that we certainly set for ourselves. But so we've had to be selective about it. But to make life more interesting, we decided quite early on in the development of our Clearwater IMS product that we would open source that itself as a complete system. Now, the benefit to us of doing that is firstly that a lot of network operators downloaded it and played with it in the lab and taught themselves what a cloud-native virtualized network function looks like, and understood the art of the possible, if you like, in this space. They're hearing a lot of different things from a lot of different vendors, many of whom have got a vested interest in kind of keeping the progress towards cloud-native NFV slow. And the fact that that here was a cloud-native virtualized network function available, several years ago, I think showed people what was possible. And of course, we got a lot of kind of free testing done, if you like, by the community. So we got a lot of early feedback about functionality, about issues, about bugs, and so on. So we were able to harden the product, more rapidly, if you like, than if we were just exposed to a few vendor labs.
Ron, go ahead.
I was going to say, add to that, I think there's another interesting aspect of open source in general, which is still nascent, but I think there's a great opportunity for us as an industry to augment how we do standards by actually looking at implementations in software, even if they're not the final version that Metaswitch as a vendor or we choose to use in production. It helps to motivate the discussions that happen in standards. Too often right now, we all read our little Word docs in 3GPP, and we all think we know what they say, and 100 companies go off and have 100 different implementations, and sometimes we're arguing over angels on a head of a pin about what the right way to implement something is, where that's not what, I'm pretty sure that's not what Google does. They go off and they write code, and the best person, the best code wins, and that's really where I think we're headed as an industry in telecom as well.
I wanted to finish with both of you on somewhat of a futurist question. Martin, I'll start with you. If we were here this time next year, talking about relatively the same topic, cloud native, and everything that surrounds that, what do you think we would be talking about?
Well, we're still very early in the cloud native journey. The vast majority of virtualized network functions available on the market today started out life as a piece of software running on an appliance. That's been ported into a virtualized environment. I think vendors who are serious about cloud native will be doing a lot of work behind the scenes to re-architect their apps and refactor their software to become more cloud native. But it's a long process if you didn't start out that way in the first place. I think we're going to see over the next year a lot of interest in containers as a way of packaging virtualized network functions. The container ecosystem isn't quite there yet for network functions virtualization, but it's getting there fast. And that's a much easier way to deploy a system that's built cloud native. It's going to make it easier to do things like network slicing in 5G, where you want to spin up a slice very, very quickly. And it'll certainly make it easier to automate a lot of the operations, which is one of the big drivers for NFV, driving operational cost out of the network. Operations automation is critical. It's easier to automate operations around containers than it is around virtual machines.
I'd add that I think as we move into 5G, the edge compute becomes less of a theory and more of a reality. And as we move in that fashion, cloud, we're going to test the limits of how cloud native software really is, and also how well we can orchestrate and automate the spin up of really a more diverse set of data centers than a few centralized. And I think that'll be a big importance to the industry as well.
So the title of this segment was a controlled sprint towards, play on words, towards network virtualization. Do you think it's a measured, Ron, actually I'll start with you on this one to finish up. Do you think there's a measured approach towards NFV at this time, or where are we on the timeline of that journey?
I think for most operators, different operators are different places in the journey, but I think that Most are at least at the point where the measured walk forward is happening. It's not like a question of if, it's a question of how fast and when different pieces come up. And that will be very different for every operator, just simply because we all have different places in time that we've installed legacy equipment, and frankly, you can't just turn that off overnight. But we're beyond the roadblocks, mental roadblocks of, well, gee, this is so different, I don't know how to deal with it. And now it's more a question of, how can I make it work to my advantage? How can I be more agile? How can I really take advantages as much as I can?
Yeah, I mean, we see Sprint making great progress and moving really rapidly in the right direction. And I think, I have to say, part of that is down to their choice of vendors. Choosing vendors who really understand how cloud works right out of the gate. The fact that we were able to come into Sprint's lab, stand up an IMS, inside 24 hours and have it passing calls. That generated a lot of confidence, and I think that confidence has started to, those ripples have spread out inside Sprint, and I think everybody's behind this and everybody's pushing to make it succeed, and certainly getting there at an impressive pace.
So we spoke to your folks over at Metaswitch a couple months back about cloud-native network functions. Again, one of the pioneers at Metaswitch in that space, and we asked you guys who would be best to be on this panel with you, and immediately you said Sprint. So then we called Ron and his team as well. So we appreciate your time and being here. I know you're very busy over at the conference in Barcelona. So
thanks for having me.
Pleasure.
Thanks for your
Thank
time.
you.
And once again, from the NMG studio right here in Barcelona, Spain, we'd like to thank our speakers. And for more information on how to be on our program in 2018, you can contact us at thenetworkmediagroup.com. So long.